We're going to look at linear, quadratic, and exponential functions, and we're going to graph a few of them. Y equals x is the parent function of a linear function with a slope of 1. It's a rising line. What happens if we change the slope to 10? That would be a steeper line like the red one. It is still a rising line because 10 is a positive number. What would happen if we make it a negative x, y equals negative x, or f of x equals negative x? You guessed it, it's a falling line like the green one. Now, what happens if we do y equals 5? There is no x at all. What would the line look like? It would look like a horizontal purple line right there with a zero slope. HOY, like hoy, horizontal, zero slope, y equals is the equation of that line. So now let's look at quadratic functions where x is raised to the power of 2. So basically your highest exponent will be a 2 and accompanying your x. That would be the parent function of a quadratic function. It's called a parabola. This one's opening up because the coefficient of x squared is 1. Now let's change the coefficient to a 10. You guess what happens. We have a narrower parabola like the red one. Now what happens if we change the coefficient to a negative number? Negative x squared. It is reflected over the x-axis. So the parent function is reflected and now looks like the green one. And the final step is to look at exponential functions. Exponential functions will carry an x in their exponent. And then there will be a base. We're going to choose the base to be 2 this time. So 2 to the power of x. Y equals 2 to the power of x. That is exponential growth. Like, for example, bacterial growth or money investments that are compounded continuously, so exponential functions. Now, what happens if we want decay instead? Well, you may think you have to make the number negative. No, not this time. Exponential decay relies on a number between 0 and 1. And there are a couple parameters. It cannot be 0 or it wouldn't exist. So then 1/2 is what I chose as an example for you. That would be a decay. So for example, a depreciation situation or half-life in chemistry and physics. So those were the 3 types of functions we've discussed: linear, quadratic, and exponential.